Welcome to all my YouTube viewers. This is AI in scientific discovery of physics. How AI is used in the scientific discovery of physics. So we could see here, as I explained in my part 1, how AI is being used in the material science. So to analyze a crystal structure, to interpret any complicating structure of atoms or materials. For all this, we are using now AI, because rather than testing a material in the lab and coming to and studying on its various parameters, it is easy to go for a simulation. So for simulation, we use this AI techniques. So you can see how generative AI in the material science market, how it has been like growing for years together. So we could see here from 2022, there are how much users are there for using this generative AI in material science market, and in next 10-12 years how it is going to rise up in peak. So now, since AI being the the key word, this is how it is going on. Here we could see AI is enabling more powerful nanophotonics. So earlier we had optics, again the study of light, and then photonics, the study of the various characteristics of photons and how we are having different various applications with photons. But this is about nanophotonics. Now recent area of research is all quantum photonics, nanophotonics. We are studying about the nano level light particle, and how these photons could be used for various technological applications. So nanophotonic components has been recently revolutionized in the field of optics, that is mainly metamaterials, metasurfaces, by enabling the manipulation of light and matter interaction. Nanophotonics is completely about the study of how light is interacting with matter. So with the various sub-wavelength, and what are the atoms and molecules getting impacted because of these light matter interactions. So the DL is a deep learning, is an efficient and an automatic platform. It enables novel efficient approaches in designing the nanophotonic devices with high performance and versatile functions. The potential of deep learning is going to be like so unfolding in the area of nanophotonics, and there is lot more applications here. When we probe into the conventional design of such components, it involves generally a forward modeling, that is solving the Maxwell's equations. We know the Maxwell's electromagnetic equations, the four famous equations, which is based on empirical and intuitive nanostructures to find the corresponding optical properties, as well as the inverse design of nanophotonic devices. So you could see here the meta atoms, the how we'll have the learning algorithms, a traditional optimizer, and a deep learning. So we use this deep learning software. Then again, how it is getting the design. So from here we draw the spectra, and we can find out from the original spectrum and from the demanded spectrum what are the different other characteristics evolved or getting impacted. So researchers at Georgia Institute of Technology have demonstrated the use of artificial intelligence in obtaining the valuable insights in the operation of photonic nanostructures, which will manipulate the light for application as signal processing, communications, and computings. So we could see when light passes inside these nanostructures, there is a collective effect of many nano elements. It results in the major changes in the spherical, spectral, spatial, and temporal changes of light. By properly selecting the geometrical features of these nano elements, we have a large system level functionalities like filtering, lensing, any frequency conversion it could be achieved. AI is used to understand the physics principles, for example, in assessing the feasibility of a response from a given nanostructure. This new approach is implemented in two steps. In the first step, the relation between the input and output of a nanostructure is highly amplified by dimensionality reduction. And by using an algorithm called an autoencoder, the information of the nanostructure response is condensed from 100 to 200 variables into 2 to 3 variables. So we go only for the reduction in size and reduction in the what is it, not going for the bulk level advantages. Now world is more looking into the much slimmer size, much compact size, right? So in that way response, if you see 100 to 200 variables is now reduced to 2 to 3 variables. It will facilitate better visualization. The technique can be extended further to obtain far more information about the physical mechanisms for interaction of light with photonic nanostructures and form new classes of nanostructures to enable the functionalities beyond the state of the art. The data analysis and pattern recognition. So we know this is all. It is a we so famous LHC, the Large Hadron Collider. The AI algorithms are used to, in this LHC through massive amounts of data being generated by particle collisions, helping physicists to identify rare events and discover new particles. The usual baryons, muons, kaons, these are all elementary particles which we have studied textually in from the school days onwards. But now every day when we see, because of this elementary particles, new level particles being discovered, the collisions between the particles, the interaction between the particles give rise to new generation of particles. So this is actually we know this is a particle collider which was built by Europe near Geneva. It is 500 feet down in 27-kilometer length to test the Higgs successfully in 2012 and other elementary particles under test. AI is typically used to analyze these jets. These jets are collimated sprays of particles originating from strongly interacting quarks and gluons. And then the astrophysics. So now we saw how it is used in the particle physics. Now going on for the astrophysics, AI helps in analyzing data from telescope space missions, identifying celestial objects, detecting the anomalies that could indicate new phenomena. Simulation and modeling. So we could see here quantum physics. AI is aiding in the simulating quantum systems which are complex and computationally intensive. So the machine learning mode can predict the quantum states and behaviors. It assists the development of many quantum technologies. So as I said, the nanophotonics, there is also something called quantum optics. So even in quantum optics, we use lots of AI technology only. Simulating the behavior of materials at atomic level is very crucial for developing new drugs, superconductors, and advanced electronics. Now, world is going towards advanced technology every day that we are in the situation to have more usage of materials at a more advanced rate. For all this, quantum optics, it is actually useful in many optical fiber communications, in optical fiber simulations, where we use this quantum optics, and there all we use is AI to solve the complex matrices and how to fabricate a soliton. Solitons are nothing but light particles traveling inside the optical fiber. So how well we could tune all these light particles is been like easily traversed only from this AI. So the Google Quantum AI is an advanced state of the art in quantum computing and developing the hardware and software tools to operate. So material science, AI driven simulations help in predicting the properties of new materials, speeding up the discovery of materials with desirable characteristics of various applications. We can see the accelerating experiments. Experimentally, if you see, AI algorithms can optimize experimental setups. It suggests the best parameters and conditions for experiments. So now, how we all know, any student now, even a school student or college student, they are good enough in using this chat GPT to write a request letter for bona fide certificate, to apply for leave letters and all such cases. So now, how chat GPT is saving the time of writing a leave letter by students to teachers. So they save their time and they invest their time in more other productive measures. So this autonomous laboratories, if you see, AI powered robotic systems can conduct experiments autonomously. You don't require a person also to stand there and monitor the temperature throughout also anywhere. So you have a AI robot there that could be like sensing the temperature now and then occasionally. It could adjust the parameters in real time based on data analysis, leading to faster and more efficient discovery processes. So in theoretical physics, as I was telling you, these are nothing but optical fibers. AI can assist in solving complex differential equations and other mathematical problems that arise in theoretical physics, providing insights and solutions that majorly be challenging to derive manually. So instead of doing it manually, and it's so challenging when we use such AI there, AI is used in solving complex Schrodinger equations in the research of solitons. It is a nonlinear, self-reinforcing, localized wave packet that is strongly stable. It preserves its shape while propagating freely at constant velocity and recovers it even after collisions with other localized wave packets. They are light pulses sent inside the optical fibers, as I mentioned earlier. So the hypothesis generation. So this is a soliton packet, actually you can see here in this diagram. And then the machine learning models can analyze existing research and data to propose new hypotheses and theories, guiding physicists in new investigations. Interdisciplinary applications we could see in biophysics, how it is used in the drug discovery, in analyzing the atomic structural changes in protein is possible. We were able to analyze this. AI is used in the biological systems in the molecule level. Climate physics again, AI is helping in the modeling and predicting of the climate patterns, how well we are able to precisely mention about there's going to be a climatic calamity, in the next hour or next 2 hours or the next day there's going to be a flood, a rainfall, a cyclone, prediction of tsunamis. All these are like possible with this AI, which is helping us in a great deal. It assesses the impact of various factors on global climate changes. In the structure of the external spike in coronavirus, this structure we were able to even predict the exact structure that the coronavirus is having some spikes outside. It was actually done by Daniel Rapp and Yuanxing Wang of the University of Texas at Austin at US. And their team, this team actually, Daniel Rapp team, was like able to obtain the structure of outer spike protein of SARS-CoV-2 that is believed to enable the new virus into the host cells. So Stephen Cassac, the head of the European Molecular Biology Laboratory in France, has graduated in physics. He spent most of his career in studying the influenza as structural biologist. So he was able to predict the structure using the AI. And now you could see here how nearly 8,000 people died in tsunami hit across Tamil Nadu on 26 December 2024. If at all we were able to predict the tsunami waves earlier itself, we would have prevented much higher deaths. So the larger number of deaths and there's a property, more than the property loss, the lives of the lives of humans, that is like very precious, and we have lost many lives in the tsunami, which could have actually been, you know, it could have been prevented if at all we were able to detect the tsunami waves earlier, and we would have given a caution for the beach people not and the fishermen not to enter inside the beach. We would have actually prevented this loss. If we had this AI tool earlier in those days, it would have been much more easier. So it can enhance all the computational methods like optimization of algorithms, data compression. The future prospects will be to explore the vast complex landscapes of string theory and quantum mechanics. It offers a new insights in forces and particles that will constitute our universe. Who knows, in near future, using a AI, even new laws of physics is also going to be possible. We are going to eradicate Einstein's theory and come up with new theory using this AI. So human speaking is going to actually reduce in near future, and we would be doing the human to human. We could do the mind reading through AI. Then we need not even spend our energy in talking to each other. We can only comprehend from their thoughts and react accordingly. That is also going to be possible in the near future using AI. Thank you. Thank you so much for watching this video. Don't forget to subscribe to my channel. Please give your likes, comments, and reviews. Thank you.